Okay. Okay. So I think let me share my screen again. Are you able to see my PPT? Okay. Yeah, you are able to see. Yeah. Okay. Cool. So today we are going to discuss about Junos OS Fundamentals. So what is a software architecture? So the Juniper architecture is completely different. It's completely developed by using Linux, FreeBSD Linux operating system. Okay. So the architecture is completely different. If you're aware of Linux, right, little bit, you're more familiar with Juniper CLI. Okay, the commands and other stuff. Okay, and what is control and forward planes, what is control plane and forwarding planes, and routing engine and packet forward engine, transit traffic and exception traffic. So we can quickly discuss about these contents. Okay, yeah, before going to do that, these are the big MX routers, and they are using these big MX routers in big data centers and service provider environment. Okay, not only service provider environment, in Amazon they are using in Amazon data center MX480 240 as a edge devices. Okay, in Oracle as well they are using, because since I've been working there, and also when I was working in Juniper TAC, right, so a lot of customers like CenturyLink, British Telecom and AT&T, and a lot of carriers, a lot of service providers, they are using MX 480 960 240 devices. And this MX104 MX80 chassis they will use at the access layer. Oh, you can't hear me? Oh my god. Thanks for letting me know. I was talking on mute, guys. Okay, so today we are going to discuss about Junos OS fundamentals. Okay, so in Junos OS fundamentals we are covering software architecture and control plane and forwarding planes. So Junos OS is developed based on Linux operating system. It's FreeBSD Linux operating system, based on FreeBSD Linux operating system. If you are familiar with Linux commands, right, you are more familiar with Juniper CLI. Okay, and we will learn what is control plane and forwarding plane, and also what is routing engine, what is packet forward engine. This is very important. And what is the transit traffic and exception traffic. Okay, so we will cover within 40 minutes we can cover all these topics. Okay, yeah, before going to that, these are the Juniper MX routers. So the routers are layer 3 devices, right? Yesterday I said, right, I have already shown you. So routers are layer 3 devices, and you can see, right, physically they are looking like this. So these MX 960 480 240 devices they are using in big service provider environments like CenturyLink, British Telecom, AT&T carrier. There are a lot of service providers, yeah, Reliance Jio and Airtel in India. So every service provider they are using this. Not only service providers, and these products we are using in data center as well. Suppose when I was working in data center, this MX480 and 240 they used as a edge devices. So people, whoever having the connection, right, so the we have a multiple data centers. At the multiple data center, the edge devices where the actual traffic is hitting into the data center, right, so they deploy these devices. Okay, not only Amazon, Oracle also they are using these devices. So lot of, so gateways, you can say gateways they use. There is a Amazon transit gateway feature is there. So the gateway devices are, these are the Juniper devices. So not only in cloud platform, they are using these devices in multiple service provider environments. So enterprise, you won't see much. These are the big devices, and these devices can handle huge throughput, and you can see millions of routes, internet routes in this big devices, MX routers. You can see there are PTX model also. So there are a lot of platforms. This is a MX platform, and it's a popular platform. That's why I'm picking these devices and showing you here. Okay, today I'm going to discuss about MX240 or MX480, which are similar to this. If you learn about one device, I will give you the hardware cheat, right? As I said earlier, you can go through the cheat and you can understand how many line cards it is having, what are the interfaces, what are the PICs, mix, and line cards. You can say MPCs, DPCs, everything. All the information will be available in hardware sheet, which is not available anywhere outside. I have it. I will give it to you. Okay. Yeah, it is available in the Juniper official portal, but you cannot get the clear picture. It will give you a lot of information. So you need important information only, right? For all the line cards and all. I just filtered it and I prepared a document and I will give it to you. Okay? Yeah, and these are the Juniper EX switches. So in enterprise, any company, hospitals or government organizations or any IT companies, everywhere you can see they are using these EX switches. So you can see 48 port switches. So all the PCs are connected to these switches. Okay, one uplink is going to the router. Okay, these are the EX models. Generally they are using 4300 and 3400, also 2300. So in data center we are using EX 5K series. 5K series, here it is 4K series. Yeah, the architecture is same for each and every platform. In Cisco we have 3 different IOSs. One is normal IOS, another one is IOS XE, another one is IOS XR. So IOS XR is it's a big IOS, and which is used in data center devices like ASR 9010. Okay, ASR 9K devices. Those are having the big chassis devices. They use those devices in service provider environment. Okay, yeah. So to be honest, Cisco is copying Juniper architecture actually. So they developed the ASR 9K based on the MX960. If you see, right, this is a MX960. So Cisco ASR 9K 9010 also it's look like same. However, the line cards also same vertically. See here the line cards are horizontally inserted. Here MX960 vertically they have inserted, right? Same thing in Cisco as well. Okay, yeah. So these are the SRX firewalls. This information you can see in my website as well. Okay, so architecture is same in each and every platform. Coming to Cisco, they have different IOSs for different platform. Like ASA platform also they have different IOS, and even in normal platform also you can see IOS X sorry iOS XE, iOS XR and normal iOS internet operating systems. But in Juniper also we have a different type of iOS, but the architecture is same. The architecture and the CLI is same. Okay, yeah. So now I'm going to discuss about what is this. This is MX960. Please focus on it. Freshers, right? Freshers or experienced candidates. After completion of this class, you can mention hands-on experience on this device also. Okay. So yeah, you can see, right, here it is showing the LED indication. This is LED indication. So this is a chassis. Are you able to see? Is it clear, right? Picture is clear, right? Okay. Can anyone confirm if the picture is clear or not? I think it's clear. Yeah. So you can see, right, these are the slot numbers of each line card and the LED indication of the each line card. Okay, if the line card is failed, see, when you join in any company, you have to troubleshoot hardware issues as well as protocol issues, where you will configure these protocols on this hardware only, right? So if the hardware is failed, suppose this particular interface is failed, maybe internally it is not reading. Okay, so the interface is down and the protocol is also down. So how you will troubleshoot the issue? First you will troubleshoot. If the SFP is having the issue, SFP you will replace. First cable also you will replace, SFP also you will replace, and then even if the issue is persisting, right, what you will do, you can check with other port. If other port is working with the same SFP, same modules, then it is working. It's a port fault. So the ports are inbuilt. If any one of the port from this line card went down, this entire line card should be RMA'd. What do you mean by RMA? Written so RMA is, so in all vendor, if any what is that, if any hardware failures, right, each and every line card have the serial number. Remember, each and every line card, each and every SFP, everything will have the serial number. If it is fails, right, you can request for RMA. Okay, when you purchase the product, they will give you a warranty, right? So RMA is return merchandise authorization. Okay, Just you need to give your shipping information and the serial number, faulty serial number, and the logs. So they will process the RMA and you will get the new product. Okay, so this is the hardware things, and let me explain more about it. Okay, this is MX960. How many line cards it is having? MX960. You will see, right? 1 2 3 4 5 6 7 8 9 10 11 12 13 14. How many it is having? 1 2 3 4 5 6 7 8 9 10 11 12 13 14. 14 line cards are there. Okay, out of 14, if you see this blue color, right, this blue color, so these blue colors are routing engines. RE, we used to call RE. Okay, we used to call RE, RE0, RE1. Okay, so these are the routing engines. What do you mean by routing engines? So each and every hardware requires a software, right? So yesterday we install our Junos OS in JN3, right? The same Junos OS we will install in routing engines. That's why we call routing engines are heart of the Juniper architecture. So it's a heart of the Juniper devices. If anything happen to the routing engine, everything will fail. Okay, so this MX960 have two hearts. It is having two hearts. If one heart is fail, one routing engine fail, right, the backup routing engine will be active. Okay, it is having redundancy because they are buying this product with huge cost. It will be minimum $20,000 or $30,000. Not only 30,000, maybe $80,000 also. Okay, yeah, it's a huge it's very cost actually. Okay, it's a very big chassis. Okay, so that's why it is using in data center, right? If it is fails, right, you will see huge impact. That's why in each and everything it is having redundancy. Suppose if you see, right, at the back side it is have power supplies. So 2 plus 2 or 4 plus 4, I'm not sure. Yeah, 4 plus 4 I guess. Okay, so 4 are active, 4 are standby. If anything happen to the power supplies, right, so backup power supplies are also there. So it is having redundancy in power supplies, redundancy in routing engines. Okay, remember this. Okay, so what these are the routing engines. So routing engine houses the software. Routing engine houses the Juniper software. Okay, please remember this. Okay, so where you will install the Juniper software, they will ask you where you will install the Juniper software. In routing engines. So you will see here, you will have a console cable here. So when you buy a new product, right, in this routing engine you will see console cable. You can log into any one of the routing engine console cable with the PC, right, through putty session or anything. So log in it, and it is coming with the default Junos software. You can upgrade it. Okay, I will show you how to upgrade Junos software also at the end of this session, not this today's session, and next week. Okay, yeah, so these are the routing engines and these are the switch control boards. Okay, if you see right, this is the switch control boards. Okay, these are the switch control boards. So first of all, if you want to install the routing engine, you need to install the switch control board. Okay, you need to install the switch control board. See, this is the SCB. Okay, first you need to install the switch control board in this slot. What is the slot? 7 and 8 slot. 0 1 2 3 4 5 6 and 7. These are the 6th and 7th slot we are using as a routing engine. So first these are the empty slots. These are the pins. Okay, you need to unplug the pins and you need to install it. If you want to remove it, you need to unplug the pins. See, these are the back plane. You know, these are the back plane. So you need to install this entire control board into the chassis first. After that, see, these are the screws. You can remove these screws and remove this empty card and insert here routing engine. Okay, so there are two components here. First you need to install the switch control board. So switch control board houses the routing engine. Okay, so you need to install the switch control board SCB first. Okay, then you need to install the routing engine. Okay, see, this is a routing, you can say routing engine is, it should look like this as well. Okay, you have to install this kind of routing engine here, and you have to install entire SCB in chassis. Okay, 2 line cards. So why we need control boards? In the sense, it provides a clock and synchronization with midplane and all. So it provides the clocks actually. Okay, yeah, I will give you the hardware cheat, what SAB will do, what routing engine will do, everything. It is there in the sheet. So it's beyond the JNCIA actually. However, I just want to explain at least one device. Okay, so yeah, so that these are the components, these are the Juniper hardware components. So far, how many components we have discussed? SCB and routing engine. So first you need to install the SCB, switch control board. After that, inside the switch control board, you need to install the routing engine. Okay, is it clear? Any questions? Any questions? No? Okay, cool. So now, okay, these are the routing engines, right? What routing engine will do? It will install the Juniper operating system. Okay, routing engines will install the Juniper operating systems. Okay, now after this, so now we need to connect the cables to the other routers and all, right? So these are the line cards. You will see plenty of line cards we have. How many line cards we have? 12 line cards. Okay, you will have 12 line cards here. Okay, so you can install all 12 line cards. See, you can install, these are the SFP models. These are the 10G SFP, 10G SFP or 1G SFP models. So whatever it is, okay, you can, based on your requirement, you can install it. So these are the line cards. These line cards we used to call MPCs or DPCs. Okay, dense port connector and multiple port connector. MPC in the sense, hello, okay, MPC is modular port connector. Yeah, so MPCs are modular port connectors and these are the dense port connector. These DPCs are legacy. Okay, these are the old cards we used to call Agent Smith card. Okay, this is legacy line cards. Okay, you can install this PFE cards in this line cards. Okay, all these are PFE components. PFE in the sense, packet forward engine. Packet forward in the sense, you can see, right, packet forward, whatever the packet it is coming, right? Suppose here there is a device, it is connecting on this interface, so it will forward the packets according to the next hop, or else if it is pointing towards this router, it will send the packets to the routing engine. Okay, these are the PFE components. PFE components are where the interfaces, all the interfaces, like GE1/0/1, all the interfaces are belongs to PFE, packet forward engines. Okay, so these PFE components are MPCs or DPCs. There are models in this PFE. So these are all our FPC slots. You can say FPC slots. In Juniper they used to call these FPC slots. In this FPC slot, you can install either MPC line card or either DPC line card. Okay, you can install either MPC line card or DPC line cards based on your requirement. We have multiple line cards. We have multiple MPCs and DPC line cards in the market based on your requirement. If you need 100G output, or if you need any other special services, IPsec services, this supports IPsec services also. Any special services, service card, any class of service card or anything based on your requirement, you can buy the line card and you can install it here. So these are the line cards. Within the line card you will see mix. Okay, these are the mix. Okay, these are the mix. Okay, these are the mix. See here, next slide I will show you. So these are the mix actually. So this is entire line card. You can see in this line card you can install up to 8 mix. Mix are modular interface cards. Okay, mix are modular interface cards. Sorry. Okay. See, suppose you have a customers with Ethernet port or SFP port. So if you need SFP, you can install SFP line card. If you need Ethernet port, you can install Ethernet line card. It's up to you. So based on, see, this is a satellite. This is a satellite port, and this is a Ethernet port. Sorry, this is a Ethernet port. This is a SFP port. This is a serial connector. This is a serial connector. See, that's what. Based on your requirement, the port connectivity, you can install required line cards. These are the mix. This is the entire FPC card. This is entire FPC card. Within the FPC, you will have mix. Okay. Yeah. This is how you can see what are the hardware components we have discussed. Routing engine and SCB, and routing engine SCB are RE components. Okay. And this MPC, DPC line cards, MPC, DPC, this mix, all are belongs to PFE components, packet forward engine. Why we call this as a packet forward engine? Because it is connecting between the routers, right? There is a router, so we are connecting a cable between the routers, right? So packets will hit on this interface first, whatever it is, right? Whatever the data you are sending, right, the packets will hit on this interface. It will check the destination IP address. It's a layer 3 device, right? It will check the destination IP address. If the destination IP address belongs to this device, it will send the packet to the routing engine. If it is not belongs to this device, it will simply forward the exit interface. Suppose okay, let me remove all this. It looks clumsy. Okay, now I'm drawing it one. So consider this is a router. Okay, consider this is another router. Okay, it is connected in here in port 1/1. Here it is connected with port 1/2. Just an example. Okay, this device IP is 1.1.1. This is 2.2.2. Just understand it. This is 3.3.3. Okay, suppose if you are pinging to 1.1.1 from this device, the packet will arrive on this interface. It will check the destination IP address is 1.1.1, so it will send the traffic to the routing engine. Okay, suppose if you are pinging to 3.3.3, it's a transit traffic. And it is not belongs to this router, it belongs to some other router, right? So you are initiating a ping to 3.3.3, the packet arrives on this interface. Okay, it will check the destination IP address is 3.3.3, and it will come to know that this IP is not belong to my device, it is someone else. So it will check the forwarding table, routing table here. It will check the routing table. So the routing table you will come to know exit path, which interface and which line card it should exit. Suppose you will have this if you want to reach 3.3.3, you have to exit through this interface. Based on the protocol it learns actually. Yeah, so it will exit the packets through this interface and send it to R3. Okay, so this is how this is called transit traffic. What is the difference between transit traffic and exception traffic? Sorry, control traffic, you can say. See, I have explained two things here. If the traffic is hitting to this device, that is called exception traffic. Exception in the sense the traffic which is belongs to this device. Okay, they will ask you one question in Juniper certification exam. What is mean by exception traffic? What is mean by transit traffic? So exception traffic is which is belongs to this device, the traffic which is goes to routing engine. The traffic which is goes to routing engine, right? That is called exception traffic. That's what I told you, right? If you are trying to ping 1.1.1, right? So the packet arrives here, it will check the routing table, destination IP address is 1.1.1. It will send the data to routing engine. That is called exception traffic. If the data is not belongs to your device, it will not send to routing engine. It will simply process here itself and exit through this interface, another line called interface. See why this is a beautiful architecture in Juniper. You know why they bifurcated the traffic like this. You know, if all the traffic will process by the routing engine process will go high, so the performance will be very low. Okay, it handles the huge traffic, and whatever the traffic which is hitting here, if it is sending to the routing engine, right, it cannot handle it. So Cisco devices is like that. So Cisco is completely based on operating system. If anything happens to the operating system, that's it. It's fully impacted. Here it is not like that. So here in routing engine, you will configure. So it houses the Juniper software, right? You will configure all routing protocols like OSPF, BGP, ISIS, whatever the routing protocols you need. You can configure it. It establishes the adjacencies, and it will build the routing tables. That is called control plane. So what do you mean by control plane? If you configure a routing protocol and if it builds a routing table, that is a control plane. Okay, so routing engine maintains the control plane and it has a routing table, because you are configuring all routing protocols in routing engine only, because it is software, right? Software held here. So you need to log in here and you need to configure here. Okay, then it will populate the routing tables. So one copy of routing table, remember, one copy of routing table it will send to PFE components. So one copy of routing table it will send to the PFE. That's the reason PFE will do route lookup here itself. It will not send to the routing engine, because if it is sending to the routing engine, it will be burden on routing engine and it will slow down the performance. Okay, that is the beauty of Juniper architecture. Okay, so in Juniper architecture we have it two components, routing engine and packet forward engine. What routing engine will do, it will build the control plane by using routing protocols, then it will populate the routing table, and after that one copy of routing table it will give to you the PFE, packet forward engine, means all line cards, whatever the line cards here it is, right, all or belongs to PFE. It will send one copy of routing table to PFE. So if any transit traffic is hitting to this device, it will do route lookup at PFE level only and forward the packet to the other interface. It will forward the packet to other next hop through different line card interface, wherever it is connected. Okay, that's it. Okay, if the traffic is hitting to your device, it will send the traffic to the routing engine. That is called exception traffic. Okay, this is a normal Juniper architecture. Okay, yeah, this is all about Juniper architecture, and this is how the Juniper device will behave if it receives any data. How the Juniper device will behave, this is the architecture, this is how it behaves. Okay, if you know the behavior of this Juniper device, if you understood well, we can go into the next topic. If you have any questions, please feel free to ask me now. Do you have any questions? Hello, raise your hands if you have any questions. If you don't have any questions, please confirm. No questions. Is it understandable easily? Okay, yeah, cool. So okay, cool. So I'm not going to the any PPT slide, I'm just explaining here the things. Okay, so now let me explain with the PPT stuff. Okay, yeah, these are the line cards you can see. Please remember the components. Okay, yeah, now in the Juniper architecture, I told you, right, it is having routing engine. This is RE. Okay, I think this color is not good. Okay, this is PFE. See here, I already written, this is PFE. See, being as a network engineer, okay, if you are learning routing protocols, you have to remember these two keywords, control plane and data plane. Okay, being as a professional network engineer, you always use these two keywords, control plane and data plane. What do you mean by control plane? Suppose if I want to go from London to Russia or somewhere else, Texas, something different location throughout the world, you have multiple paths to reach one destination. Okay, you have multiple paths to reach one destination. Okay, that is called control plane. So listen carefully. You have configured the routing protocols and you learn the route to reach the destination. Suppose Google route 8.8.8, you have installed in a routing table through OSPF, BGP, whatever the routing protocols, and each routing protocols you have multiple paths. So that is called control plane. So what control plane will do, you know the thing very well, you know how to reach destination, how many available paths to reach destination. Okay, please remember control plane is, it will deals with the routing protocols. What they will ask you in interview. Okay, what is mean by control plane? So it deals with the routing protocols and build a routing table and all the available paths to reach the destination, right? It will be in routing table. That is called control plane. Okay, yeah. What is data plane? We have multiple available paths. Which path I am choosing it? Which path I am choosing it? It's very important. See, you are a person. Okay, you are a person. You are living in a big home. You have multiple gates to go outside. Multiple gates. So multiple exits to go outside. Okay, this is called control plane. How many exit paths you have, right? So that is called control plane. But actually, which path you are choosing it? You are going. These are the 1, 2, 3, 4. Which path actually you are going through? If you are going through gate 4, right? That is called data plane. So this information, which path you are choosing it, right? The best path information will be there in PFE, packet forwarding engine, and the data plane, you can say. Okay, this packet forwarding table, you can say forwarding table. Okay, is it clear? So control plane is located in routing engine, the data plane will be in PFE. That's why, right, this is the data plane. How the data is hitting it here on the interfaces, this is the PFE component. So the data is entering here and exiting here, right? 1 second, guys. Sorry. Okay. Okay, yeah. So we have routing engine components, we have daemons. Okay, we have daemons. Daemons means it's not a ghost. Okay, daemons means it's a processor. So within the routing engine we have a multiple processors. Okay, so what are the processors? MGD, RPD, DCD, chassis. So like that we have multiple processors. Suppose, what is RPD? It's a routing protocol daemon. Okay, it's a routing protocol daemon. If you configure any routing protocol, right? Suppose in your Juniper router you are configuring OSPF or BGP or any routing protocol. If you are configuring any routing protocol, right, who will responsible to process all these things? RPD. In Juniper architecture, this is a daemon. Okay, so suppose if your routing protocol is not working as expected, right, if it is a bug, right, you have to restart this process. Okay, if you so every routing protocol, whatever it is, all the routing protocols will process by RPD. Okay, remember, so it will take care, RPD will take care of routing protocols. Now what is DCD? See, you are configuring IP addresses on the interfaces, right? Here suppose this is 1/1 port, you are entering this port and you are assigning the IP addresses on these interfaces. Whatever you are assigning these interfaces, right, everything that will take care by DCD. Okay, so in the next slide I'll explain everything about DCD. Okay. Next is MGD, management demand. So suppose if the management traffic, right, management in the sense like the management traffic, CLI information. So everything the everything will be taken by MGD. And the chassis D. What is meant by chassis D? See, this is all chassis. It's a big chassis. Suppose if this chassis is having any hardware errors, so it will generate alarms. Suppose if this chassis is failed due to some hardware issue, so it will generate alarms. Okay, who will generate alarms? This chassis D will generate alarms. Okay, chassis daemon will responsible to monitor all the line cards. Okay, Okay, this chassis D is responsible to monitor all the line cards and SFPs. So these are the line cards, right? All this information, if the hardware is failed, how it is it healthy or not, if anything having any error, everything it will generate. Who will generate? The chassis D. Okay, so there is a question, guys, about RPD. Who is responsible for routing protocols? In Juniper certification they will ask you. Okay, it's a live exam question. So what is it? It's routing protocol daemon. Okay, now in the PFE you will have PFED, packet forward engine daemon. So what it will do? I said, right, the routing engine will share one copy of routing table to PFED, so that information will controlled by PFE. Okay, yeah, so this is the internal architecture. If you see, right, this is a routing engine, so this is a routing engine. Okay, in this routing engine we have software, Junos software. In the Junos software you have all these processes. Okay, yeah. This is the architecture of Juniper. Okay, see, this is a control plane. The routing engine is a hardware module, is a central control point for the system. It's a heart of the system. So whatever we have discussed, I have mentioned here, please read about it. Okay, yeah. So as I said, right, it's FreeBSD Unix operating system, Unix or Linux. Yeah. So next, routing engine components, as I said, routing protocol daemon and device control daemon. So the see, routing protocol daemons are controlled by the routing protocol routing protocols. The routers routing protocols are controlled by the routing protocol daemon. Okay, whatever it is function, it includes functions, messages, routing table updates, everything will be taken care by RPD. Next is device control daemon. The router's interfaces, as I said, right, if you configure any IP addresses on the interfaces, the router's interfaces are configured and maintained by this DCD daemon. Okay, so why we have these daemons? See, if anything happened to the particular processor, right, it won't impact on other process. So that is the beauty of Juniper architecture. Again, I am telling you. So we have multiple daemons. If anything happened to this, see, Cisco is not like that. Cisco is completely based on software. If anything happened to the software, everything will be destroyed and you will see full impact. But Juniper, see, if anything happened to the RPD, it won't impact on others. You will still have the access to the device. Okay, so if anything happened to the DCD daemon internally, RPD it is running, and MGD, the management daemon process, as I said, chassis D and PFED. Okay, so there are a lot of daemons we have. If you use class of service, you have class D, and if you use SNMP protocol, you will have SNMPD. Yeah, you have multiple daemons. Okay, yeah, these daemons are routing engine components. Okay, now these are the PFE components. I told you already. See, these are the line cards. You can say MPC or DPC. Okay, so DPC are old line cards, focus on only MPCs. So these are the chipsets. So see, this is input output chipset and lookup chipset, memory chipset. So there are multiple chips. This we used to call ASICs. If you are a electrical student, electronic students, right, you will understand. Actually, I did a MTech in VLSI domain. I was more passionate about these Juniper devices, because not only networking, perfect job role for electronics and communication engineering domain people, right? So I was very happy. At least whatever I have studied, right, I was working on it. So yeah, so if you are an electronic student, you will understand these are the specific processes, like application specific integrated circuits. Okay, each process, like, see, the data will hit it here. This is a interface, right? Exactly at a hardware level, if any data hit it here, right, so we will have a separate chip, ASICs. So from there it will do, this is a memory chip. Whatever the routing information, everything will be stored in this memory chip. And this is a lookup chip. As I said, right, it will do the routing lookup. Routing lookup means it will check the destination IP address in each and every packet, right? Yeah. this is QX, this is another lookup. So these are the first generation of line cards. They increase the throughput in each and every generation. And see there, here you will see 4 ASICs, then 3 ASICs, 3, and now Eagle chipset, only one chip. So they integrated all the chips in one chip. Okay, so this is completely at a hardware level. You don't need to remember, but if you are fascinated about hardware as well, right? So this is the information. Okay, yeah. So as I said, right, transit traffic and exception traffic. What do you mean by transit traffic? So if the traffic is hitting to, suppose if we are trying to reach 1.23, so this is a device, right? This is called so these are the routers. For these routers, this is called transit traffic. It is not going to this device, right? Any of this device. It is going to some server. So what it will do, if you initiate a ping to 1.3, the packet arrives here. It will check the destination IP address is 1.3. Hey, this 1.3 is not belongs to me. So it will forward to the next hop. Okay. And similarly, this middle router will also will forward to the next hop, and the last router will forward to the server. So all these three routers point of view, this is called a transit traffic. The traffic which is not belongs to me is called a transit traffic. If the traffic is belongs to me, and if this is destined to the routing engine, okay, routing engine should process, right? The routing table, the main routing table is located in routing engine, and it will process it and it will respond it accordingly. That is called exception traffic. Okay guys, you will get one Juniper certification question here. So if the traffic is pointing to the routing engine, right, that is called exception traffic. If the traffic is pointing to PFE, that is called transit traffic. Okay, this is all about Junos OS fundamentals. Okay, this is all of, we discussed more actually. We discussed more. Okay, I would like to teach more also. If you enroll in JNCIA as well, it's a very good concept. We'll dig into more. Okay, cool. So any questions, guys? Junos OS fundamentals. If you clear right about these topics, next we'll practice with Junos CLI. Whatever we have discussed, I will show you on the Junos CLI, as well as, since it is a lab software, right, you won't see much information. You will only see 70% of the information only. Okay, yeah. So any questions on these topics? If you have any questions, ask me. Any questions? Everyone? No. Rajesh, Shinu, Hindu? No. Okay, cool. So today at the end of the session, I will give you all important questions. Please prepare those questions. Those questions are directly, you will get it in, those are dumps questions actually. Dumps. Okay, DUMPS, dumps, examination questions. So if you start practicing it, right, I will ask you in the WhatsApp group also. Please respond it, and later I will share the document also. Okay, yeah, you have to write 2 exams, guys. One is voucher assessment exam, so next one is main exam. So after end of this class, I will tell you how to see, you no need to complete the 19 modules. If you are interested, you can complete it, or else you are already listening to me right here. You are already participating in these classes, so you no need to complete all the 19 modules. Instead, you can directly write a voucher examination. Okay, directly click on 20th module, start writing the examination. And so the voucher exam will be next Sunday. Everyone should join the call. Everyone is writing the voucher exam at the same time. Okay, I'll be there on the call, and each and every question I'll show you, and I will ask you the answer, and I will give you the right answer as well to get a voucher. Okay, maximum you will answer it. It's easy only, but make sure we don't miss the opportunity, right? Yeah, that's the reason. Everyone, next Sunday, if Sunday is not possible, next week, based on your availability, we can write the voucher assessment exam. Okay, yeah. So any questions? If you don't have any questions, we can take a 5 to 10 minutes of break, and we can start CLI. we can start labs. How you will assign the IP address in Juniper, how we will configure the things, what are the important parameters you need to configure in Junos CLI. Everything I will explain now after the break. So I just let me know if you have any questions, I can discuss. Eddie, do you have any questions? And Sindhu, Shravan, Rajesh, if you understood, please raise your hands. At least no questions. Okay. Okay. So maximum people voted. It's great. Everyone is understood. That's nice. Okay. Cool, guys. Take a break for 5 to 10 minutes, and we can quickly jump into Juno CLI. Okay. Yeah.